Okay, here we go. Problem number 6. Solve this using Gauss-Jordan by hand, REF, and so reduced echelon form and AX equals B form. So I'm going to do by hand because that's where most people need the review. So first things first, remember we eventually want a 1 on our x variable in the top left corner. So I'm going to just start by writing this equation in the top left corner, or the top row. So it's going to be 1, 2, negative 4, negative 17. Then the other ones, it doesn't really matter. I'm just going to, because my brain works this way, I'm going to write row 2 in row 2, and then the top one I'll write in the bottom. So that'd be 10, negative 1, 1, 7. Before you get going on any problem, make sure you copied them all in right, because one little mistake and all of a sudden you do a whole bunch of work for nothing. So 1, 2, negative 4, negative 17, correct. 9, negative 2, 4, 7, correct. 10, negative 1, 1, 7, correct. Okay, so here we go. I'm going to pivot around the 1 using that number to get zeros below. So therefore, I'm going to say I need negative 9 row 1s plus row 2 to make a new row 2. And I'm going to use negative 10 row 1s plus row 3 to make a new row 3. And this would result in the following matrix. So the top row not going to change. There we go. Next row, when I add, well, by design that's got to be a 0. So now I'm doing negative 9 times negative 2, it's negative 18. Add those, that makes negative 20. Negative 9 times positive 4 is 36. 36 plus 4 is 40. And then negative 9 times a negative 7 makes a positive 153. So then a positive 153 plus 7 makes a positive 160. Okay. Then for the bottom row, again by design that's a 0. Multiplying negative 2 times 10 is negative 20, so that makes negative 21. Negative 10 times negative 4 is positive 40, so that makes a positive 41 when you add them. Negative 10 times negative 17 is a positive 170, plus 7 makes a positive 177. And now I ask myself, have I used my first pivot completely? Am I done with it? Well, yes I am, because I have zeros below. So now I'm going to move along in the diagonal. And I notice this whole row is all divisible by 20. So if I really wanted to, I could have said take this whole thing and multiply it by 1/20th, or divide by 120. So that way, and actually make it a negative. So that way, it's taking all these numbers and dividing them by negative 20, which would result in positive 1, negative 2, and negative 8, making it much easier to work with. So now when I pivot around this point, just the smaller numbers. So I'm going to need negative 2 row 2s plus row 1 to make a new row 1, and 21 row 2s plus row 3 to make a new row 3, and we continue as we do. So that's going to remain as 0, 1, negative 2, negative 8, because we're not changing row 2. Now when I add that should be not negative row 2 row 1s, that should be negative 2 row 2s. There we go. So when I multiply row 2 by negative 2, the nice thing, my top left number still stays a 1. It's not going to change at all. Then by design, that has to be a 0. Now, kind of neat part, negative 2 times negative 2 is positive 4. Positive 4 with negative 4, that makes 0. That's helpful. And then, again, negative 2 times negative 8, that's positive 16, plus a negative 17, so that's just negative 1. So that kind of fell out nicely. Let's hope the next row does the same thing. Now, by design, yes, I am multiplying by 21, but 21 times 0 is 0, so that's easy. Then 21 times 1 is 21, plus a negative 21, that makes 0, so that's easy. 21 times negative 2 is a negative 42. Negative 42 plus 41 makes a negative 1, so that was easy. Then negative 21 times is a negative 168. Then when we add that with 177, we get 9. So this row is almost perfect. The only issue for our third row is we would like this to be a positive 1, not a negative 1. So up here you can just say, hey, multiply this whole row by negative 1. Now so that way that's a positive, that's a negative. And we're ready to pivot again. Because are we done with the pivot? Well, yes we are, because we have zeros above and below. So now we're going to move along in the diagonal once again. And we're going to pivot right here. So I say, well, the top row is already done, so I just need 2 row 3s plus row 2. And the top row, first row, we're not changing. The third row, we're not changing. So now we just have to do the middle row. And the nice thing, by design, all of this stuff is really easy to do. That has to be a 0. 2 times row 3 is 0. 0 plus 1 makes 1. So that didn't change. And then by design, that has to be 0. So now all we have to worry about is our 2, 4 entry, the equal sign right here. So 2 times negative 9 is negative 18. Negative 18 plus a negative 8, it makes a negative 26. So now, if you leave your answer like that, you're wrong. Don't forget, you have to tell me how to read it out of here. You have to understand what this matrix is saying. And remember, this is the x, y's, and z's. So therefore, I'm hearing x equals negative 1, y equals negative 26, and z equals negative 9. Or we just remember this is an ordered triplet since there's no context, so it's negative 1, negative 26, negative 9. Now, you could have gotten the same thing by just taking this matrix, typing in the calculator, and saying reduced echelon form. But I also want to remind you of the AX equals B form, which is very, very similar. All we're going to do here, let me grab this little piece right here, and I want to copy it. Okay, so over here, there we go. The only difference between the two forms, it's really not much. For the AX equals B form, all we're going to do instead is we're going to keep our same main part of the matrix. We're going to keep the 1, 2, negative 4, 9, negative 2, 4, excuse me, positive 10, not negative 10, 10, negative 1, 1. But then we just remember it's matrix multiplication, so this is x, y, z, and this whole thing equals negative 17, 7, 7. Now, we could get the answer to this just by simply putting in our graphing calculator the A matrix and finding what A inverse is, then taking our B matrix and multiplying A inverse times B. Because if you remember, our matrix arithmetic, how we get through this matrix algebra. If I want to get rid of a matrix A, I have to multiply both sides by A inverse, and if I multiply on the left, I have to multiply the other side on the left, other side of the equal sign on the left. So then A inverse times A, that makes the identity matrix. The identity times anything is always just that thing. So all we're typing in our calculator is A inverse times B. Okay, best of luck.